بسم الله الرحمن الرحيم. أهلا وسهلا بطلاب المرحلة الثانية في تسجيل المحاضرة رقم 5 اللي هي about insulin and its mechanism of action. Introduction. Insulin is a peptide hormone produced by beta cell of the pancreas, and it's a central regulation of carbohydrate and fat metabolism in the body. Insulin causes cell in the liver, skeletal muscle, and fat tissue to absorb glucose, so it facilitates transport or entering of the glucose from the blood into this cell. In the liver and skeletal muscle, glucose is stored as glycogen, and in the fat as a triglyceride. When the control of insulin level falls, diabetes mellitus can result. As a consequence, insulin is used medically to treat some form of diabetes. Structure of insulin. Human insulin consists of 51 amino acids, which consist of 2 chains connected by disulfide bridge, as shown in CC. I need to show pointer, laser pointer. This one, C-peptide, disulfide bridge, and this disulfide, and between A chains and B chains, and there is intra-disulfide bridge within the A chains. During the transmodification of disulfide, the molecular weight of the human insulin is about 5.8 kilodalton, and the half-life time of insulin is about 10 minutes. Degradation by glutathione insulin transhydrogenase or insulinase, which is a cleaved the disulfide bridge between the chain. Bovine insulin, which is type of animals, differ by 3 amino acids, while pork insulin differ by 1 amino acid. So in previous time was used insulin from the pork to treat diabetes mellitus. Insulin is stored as a complex with the zinc ions. Biosynthesis of insulin. Insulin formed in 3 steps. Step 1, insulin synthesis as proinsulin in the pancreas of the beta cell, which contained a single peptide. There is no connection, there is no bond between the chain, between A chain and beta chain and B chain. In rough endoplasmic reticulum, then cleavage as a peptide in rough endoplasmic reticulum, converting to the proinsulin to the Golgi network. Proinsulin undergoes maturation into active insulin. Active insulin, that one, known as prohormone, converts BC1. Prohormone converts BC1 and BC2 as exoprotease carboxy prohormone carboxypeptidase. With this one, hormone response to convert the pre-insulin to proinsulin. The peptidase cleaves to position of releasing fragmentation called C-peptide and C-peptide change linkage by disulfide. This cleavage are reached to located to cleavage in the carboxylase. So this one converts the prohormones carboxylase, and that one vacillate to carboxylation or the formation of the disulfide bridge on the carboxylase responsible for cleavage of the C-peptide and that one, resulting in mature insulin granules waiting for the metabolic signal such as leucine and mannose and vagal and vagal nerve stimulation to be exocytosis from the cell to the blood circulation. So even there is proinsulin, pre-proinsulin converted to the endoplasmic reticulum to proinsulin to form disulfide bridge and a culture produce form active insulin. They uh, formed in the vesicle and cannot be exocytosis, even they still waiting for the signal coming from leucine, arginine, glucose, adenosinase, and by this signal, mature insulin to be exocytosis to circulation. Regulation of insulin, even the insulin exocytosis to bloodstream, there is not haphazard, there is a regulation of this production, endogenous production of insulin regulation in the several steps, along with the synthesis of the transcription from first one transcription from the insulin genes, another formation of the messenger stability or at the messenger translation, and the post at in the post-translation modification. Each of those could be used to regulation of insulin in the circulation, to be stopped, to be regulated, depend on the required by the cell. Effect of insulin of glucose uptaking of the metabolism. The first insulin bind to insulin its receptors in the cell membrane and start protein activation cascade, and eventually this activation cascade include activation of glucose transporter to the plasma membrane and influx or flip glucose to the cell membrane. Eventually it led to the glycolysis triglyceride. So in this figure shows that insulin activation in its receptors and receptors led to activation many protein inside of the cell, including activation of glycogen synthesis, protein synthesis, and activation number of glucose transporter, especially for glucose transporter for the cell membrane, led to vacillate large number from the glucose to be flipped in the side of the cell. Mechanism of actions. What happens when the insulin to be exocytosis in the bloodstream? Insulin acts a specific receptor located in the cell membrane, particularly in every cell, but their density depends on the cell type. Liver and fat the cell are rich, so the receptor are rich. What the receptor is? The insulin receptor is receptor tyrosine kinase. Receptor tyrosine kinase is a heterotetramic glycoprotein consists of two extracellular of alpha and two transmembrane of beta subunit linkage together by disulfide bridge. Such it's insulin. The receptors are there is disulfide bridge and there the tensor. This bend between chain A and chain B. This between beta subunit and alpha subunit binding. Alpha subunit binding for the hormones and B subunit binding for ATP binding tyrosine kinase. It's oriented across the cell membrane as a heterodimer. This alpha subunit carry insulin binding set, while the beta subunit have tyrosine kinase activity. Insulin signaling pathway, as I said before, insulin receptor activation of ATP and ATP receptor activation mini receptor, ending with the cell growth, gene expression, increase protein synthesis, increase glycogen synthesis, increase anti-lipolysis gene expression, increase glucose transporter to be production from the vessel, and increase the number of this transporter in the cell membrane, increase and eventually increase number of glucose to be in from the bloodstream. Mechanism of actions. Insulin stimulation glucose transport across the membrane by ATP dependent on translocation of a glucose transporter, especially GLUT4 to plasma membrane. This second messenger of phosphatidyl phosphate 3 and certain tyrosine phosphorylated guanine nucleotide exchange protein play important role in the insulin-sensitive translocation of GLUT4 from cytosol to the plasma membrane, especially in the skeletal muscle and adipose tissue, which GLUT4 be present there. Over period of the time, insulin also promote extra expression of the gene directly in synthesis GLUT2 gene for the large number of enzymes and carrier are regulated by insulin through RAS and RAF, which it be shown by you from the Google map kinase as well as through the phosphorylation cascade. Degradation of insulin. There is a great regulation between insulin formation or insulin biosynthesis and insulin degradation. Degradation of insulin, the internalized receptor of insulin complex, either degraded intracellularly or returned back to the surface from where the insulin is released extracellularly. The relative preponderance of these two processes differs among different tissue. Maximum degradation occurs in the liver, least in the vascular endothelium. So is the maximum in the liver and in the minimum in the vascular endothelium. Fate of insulin. There is many pathway for insulin. Insulin distributed in extracellular, its peptide gets degraded when they come orally because there is high acidity in GIT when given orally. So it's the important thing, the injection of insulin or that release from the pancreas metabolism primarily in the liver and the smaller extent in the kidney and muscle. So no way to we take oral dose for insulin. Nearly half of insulin entering the portal vein from the pancreas is inactive in the first passenger through the liver. In the first passage, when you move in the first passage, those normally liver exposed to a much higher concentration, 10 less than 10 from 4 to 8, roughly about 6-fold increasing insulin than other tissue, and there is maximum concentration of insulin in the liver than other tissue because near to the source. During biotransformation, the disulfide bond are reduced A and B chains are separated. You know, during biotransformation, when you become long way, long tissue for the long distance uh, far from the liver, the activity to be less. These are further broken down to constitute amino acids. The plasma half-life time is about 8 minutes, from 5 to 9 minutes. And there is different type of insulin preparation depend on the which insulin. There is rapid action, short action, intermediate action, and long action, and each action has uh, onset or have different onset or and different peak, different duration, and so and there is another um, type, sometime mix of the rapid action and long action to form um, the intermediate action to be suitable for large number of patients. In conclusion, diabetes mellitus is affected by insulin, which is effective in all form of diabetes and is must for type 1 causes as well as for the post-pancreatic uh, pancreatomyelitis diabetes, which is related to disease in the pancreas, gestational diabetes, which occurs for the women with the pregnant women, and many type of type 2 causes can be controlled. Insulin therapy is generally starts with regulated insulin given before each major meal. The requirement is depend on the test is different from patient to another, different environmental, different in the family history, depend on the activity of the person. So the important to be test of the blood test or urine test or both of them. Diabetic ketoacidosis, diabetic coma, regulated insulin is used to correct the metabolic abnormality, usually within 4 to 6 hours. Blood glucose reach to 300 milligram per deciliter. The rate of the infusion will reduce to uh, 2 to 3 units per hour. Hyper hyper hyperosmolar non-kinetic hyperglycemic coma. This is usually occurs in elderly type 2 diabetes mellitus cases. This cases is obscure. This generally principle for treatment of the same as for ketoacidosis coma, which insulin faster fluid replacement to be instituted as alkali as usually not required. And thank you very much for your listening, and I need you to uh, write a short essay to me to be uploaded as a part of the homework about uh, different type of liver cell, such as alpha, beta, gamma, delta, and which type of hormone insulin and how this hormone to be regulated by these hormones. Thank you.